Hi and welcome. Now we are going to see some methods of binary search tree. That is how we will insert elements in our binary search tree, how we will delete elements from our binary search tree, that is BST. Okay, and then how we will find the minimum and the maximum element in my BST, or how we will find any element in my BST, correct? So we are going to see these four methods now. Now you are very familiar with the properties, correct? You have learned all the properties of binary search tree. So if I want to insert these elements in my binary search tree, I think you can do it. I think you can absolutely do it. So just draw a binary search tree and keep it aside, correct? And then just cross check after I have done with this, correct? So what is the first step is we need a node. We need a node. If we are doing this in C, we need structures, but here we will need a class node for creating the node where our data value will be stored. Fine. So first we will define a node. We have done this previously also in trees, that when class node we have, and we will define our data value inside it, and we will define the left pointer and the right pointer also. So node left comma and right. Okay, so we'll define these two pointers here. Then node, this is a constructor to initialize my data value. This dot data equals to item, and then the last one is simple, left equals to right equals to null. So we have created our node now. We have created our node. So in our node we have a data and a left pointer to point to the left elements and the right pointer to point towards the right elements, correct? So after this we need a root. We need a root. So in our BST method class I will define a root of type node, so node root. Fine. And a constructor BST methods, and I will initialize this root to null. I will initialize this root to null. So whenever I want to create my binary tree, I will go to my main method, that is my main class. Okay, using the node class I will create the node, and using the BST class root variable, what I will do, I will simply initialize the root variable to null. Fine, this is the basic step. So what I have now, I have my root, okay, which is basically null right now. I have a root which is basically null right now. Right now I want to insert 50. I want to insert 50. So to insert 50, the root is currently null, so I can directly insert it. That is not an issue here. So since my root is directly null, initially null, so I can directly insert 50 to my root. No, okay. Then the next value is 25. So to insert 25, I have to check whether it is less than the root or it is greater than the root. Okay, and you have seen the property that the elements are unique in BST, so it won't be equal to root. So it is 25, so it can be less than, so we will go to left. If it is greater than, we will go to right. Okay, so it is 25, so since it is 25 is less than 50, so we will go to left. And we will check whether the left child is empty or not, whether the left child is null or not. Since it is null, we can directly add 25 here. Next is 15. Now in this 15, we will again begin from root, and we will check whether 15 is less than 50 or greater than 50. Since it is less than 50, we will go to 25. That is the left child. This time the left child is not null, so we'll compare with this child whether 15 is less than 25 or greater than 25. Now as you know that 15 is actually less than 25. So now again we will go to the left side and we will check whether the left child is null or not. Yes, it is null, so we can insert. If it is null, we can insert. We inserted 15. Then it is 75. For 75, again check from root. Is 75 greater than 50? Yes, it is greater than 50. So this time we go to the right child and we will check whether the right child is null or not. Yes, the right child is null. So here 75 will be inserted. Then we go to 30. In case of 30, we have to check from the root again. So 30 is less than 50, so we go to 25. And now tell me what will happen. Just think what will happen, whether it will go to left or right. It will go to right because 30 is greater than 25. Now what will be the next step? What I'm checking first, every time I'm checking is simple, whether the right child or the left child is null or not. If it is null, I will directly insert it. If it is not null, then I will compare it with the value, correct? And then again I move downward. So insert 70 here. What we will do for 70? So we will check it with 50. That is correct. Then we check whether the right child is null or not. No, it is not null. So it is not null. So we'll compare the values, correct? I have told you this. So 70 is less than 75 or greater than 75. Do 70 is less than 75. This is true. We will go to right or left. This time we will go to left, because since 70 is less than 75, so we will go to left. Now what is the next step? Whether we will directly insert or there is a condition first. There is a condition first. And what is the condition? If the left child is null, only then we can insert. Correct? Yes, it is null right now, so we can insert directly 70. Then we check for 85. Again, now you know the whole process. Now I explained the process very well. Then 85 is here. So is 85 greater than 50 or less than 50? Greater than 50. So we will go to left or right. Just think, we'll go to right. Now I am in right. So whether we directly insert or check for the condition, we will check for a condition. And what is the condition? Condition is simply that the 75, and the condition is whether the right child is null or not. No, it is not null. So we will compare. So compare 85 with 70. So what is 85? 85 is greater than 70. Now think whether we go to left or right. Since it is greater, we will go to right. And then again we will check for a condition whether the right child is null or not. It is null, so we can directly insert it now. So 85 is here. Now I think you can completely draw the tree and insert the rest of the element, that is 10, 23, 46, 84 and 90. Insert these elements also correctly inside the tree. Pause the video and insert it. And after resuming the video again, just cross check. So what will be the next element? 10. 10 will be inserted here because it is less than 15. Now it is 23, so 23 is less than 50, come here. 25 less than 25, come here. Greater than 15, so insert here to the right side of it. Now we have 46, so 46 is less than 50, greater than 25, greater than 30, so we have to insert on the right side of it. Then 84, 84 is less than 85, so we will come here. And the last element is 90, which is greater than 85, so we'll come here. So this is my complete BST that I want to draw, I want to construct. So these are my insertion and these are my complete binary tree. So I have actually told you the steps that we will do in our code. So what will be the step? The first step is to check whether root is null or not. If the root is null, then the first element is inserted as the root. That is the first step. So yes, we know what is the first step. What is the second step? If root is not null, then compare. What will compare? Whether the value is less than or greater than. If it is less than, then go to the left side, and if it is greater than, then go to the right side. Okay, so this is simple. And after going to the left and right, again we have to check the first step again, that this is null or not, that the node we are currently in is null or not. If it is null, simply insert. If it is not null, then compare again and go to the left or right, make that decision. So we have just 3 or 4 steps in insertion and nothing else. Okay, this is a recursive process, so only these 3 steps will be recursively executed. Okay, so this is very simple. I think you have basically understood how the insertion will happen. Okay, if you want, you can try the code by yourself. Okay, I have told you the steps. You can try the code by yourself and just pause the video and try the code by yourself. Okay, now I'm going to write the code, and you can cross check it if you have paused the video, or if you haven't paused the video, just see and try to understand the code. Okay, I will explain the code also. Now in my BST method class, I am going to create the insertion method. Okay, the method to insert the elements. Now you have seen that during insertion we need actually 2 things. We need the node to check whether the left child or the right child is empty or not, and we need the key or the data value to insert it, and a node for checking whether the left child or the right child is null or not. Correct? We are doing these 2 steps every time. So we need 2 parameters. But from the main class, what I can do, I can just pass a single parameter, that is data. The reason is every time we are checking from root. So the node variable can simply be root, and in the recursion it will update. Simply update. So what I can do is void add, that is an insert method, int key. So the main method from the main class, I will simply call this function with the data value as key. Okay, and from here what I will do is I will create another method, for example add node recursively, and here I can pass these 2 parameters, that are root and key. So from the beginning it will be root. Every time we will check from the root. I have shown you this. Every time we will check from the root, and in this method I will update the node. To the left child or to the right child. Okay, now let me create that method. So node add node recursively. I will create a node that will contain root, and then it will update accordingly. Okay, so next is int key. Fine. So these are my 2 parameters that I wanted. Now I have both of those parameters. Now what was the first step was to check whether the node was null or not. Okay, if the node is equal to null, then we can directly insert. The node equals to new node key. So what is happening here? This object of node class is created with the data value as key, so it will go here. Here the constructor will be called, data value will become the key, that is the item, and left equal to right becomes null. So a new node is created and that is pointed by my reference variable node. Then I will simply return my node. This is done. If node equal to null, I have told you that you can directly insert. But what if the node is not equal to null? Then what you have to do, you have to check whether we have to go to the right side or we have to go to the left side. Okay, so let's now do that. So if my key is less than node.data, so what will happen if my key is less? We go to the left side of it, correct? So node.left equals to add node, we will call this function again add node recursively, and we will go to the left side, node.left comma key. Okay, so we will go to here again and it will insert it, I will show you how it will insert. Then if it is not this case, that is else if the case is key is greater than node.data, so we have to go to the right side. So node.right equals to add node recursively, and what I will pass, I will simply pass node.right comma key. Okay, so these two parameters I need every time I want to add any value, correct? Now what is happening here, the first one we are checking that if the node is null or not. So if the node is null, we will simply add it. Now we are checking that whether the node is, if the node is not null, then we are checking if the key is less than the node data or it is greater than the node data. Okay, if it is less than the data, we are going to the left side, and if it is greater than the data, we are going to the right side. And the last, I will simply return the node. Fine. So this is what is happening. This is just the insertion code. We are inserting the elements using this. Okay, and this is BST. We are checking this condition, whether it is less than or whether it is greater than. So this is the same code that I have explained you here. What is happening here, when 50 is coming, it is checking to the first condition. What is the first condition? That is node is null or not. So when 50 was coming in the beginning, node was null, so 50 is inserted directly. When 25 was coming, node was not null, so this statement was not executed, and we go to the second one. Whether it is small or greater, it is smaller, so we go to the left side of it, and it is inserted on the left side. Then what we come, then 15 came and we came to the left side of 25 and we inserted it here. So this is how the code is working. Now let's see this code in action. Okay, so this is my code, correct? So let 50 come. So first value that is inserted here is 50. So when 50 comes here, it will see that node equal to null, there is nothing inside it, so it will simply create a new node with the key value as 50 and it will insert it. Okay, so a new node is created with a key value as 50 and it is inserted, data value as 50 and it is inserted. Then the next 25 came. Now it will check that node is not equal to null, because at first node will point to root, so node is not equal to null, correct? Then it will come in the second position. Now here it will check whether the key value is less than the data value or not. So 25 is less than 50, correct? So where it will go? It will go to the left side. And this function is called again. Now when it goes to the left side of it, as you know, currently it is null. So node.left is nothing but null. So in node what will come? Null will come. So this condition will become true. And here with the key value as 25, a new node will be created and 25 will be inserted. This is that simple to understand. Then 15, the next value is 15. So again it will begin, obviously it will begin with root. So 15 is less than 50. We go to the left side. Now this time it is not null. So node.left is actually 25. So we come again here and again it will check whether node is null. No, it is 25. So we come here. Whether 15 is less than 25? Yes, it is. So we come here again and we go to the left of 25. So what he will find in the left of 25, he will find that node.left is nothing but null. So now it becomes null, key value is 15. So node equal to null, key value is 15. It will create a new node with a key value as 15 and it will simply insert it. So this is how this recursion function is working. Okay, we will see one of right side also. So 75 will be inserted. How? If node is equal to null, no, it is 50. So we come here. If key is less than node of data, no, it is greater. So since it is greater, we will go to the right side. Now in the right side at beginning there is nothing, this is null. So this value becomes null. Since this value becomes null for this, we come here again because this is recursion and node equal to null will become true. Since it became true, what will happen? Node equals to new node. With 75, a new node will be created and it will be inserted on the right side of 50. Similarly for 30, 30 will be created here. So I have drawn the tree before. This was to explain you how the code was working, correct? So now I think you can complete the whole tree with the help of code also. This was easy. The insertion in a tree is comparatively easier, okay, in BST, because what we have to do, we have to just do three things. Check whether the node is null or not. If it is null, just create a new node and insert it. The second step is check whether the key value is less than or greater than. If it is less than, go to the left. If it is greater than, go to the right, and the function will take care of the rest. So this was simply insertion. Let me insert some values now from the main function. Now in my main class, what I will do in the main method here, I will create a BST method. BST methods tree is, what is my tree? Just think, what is this? This is a class, correct? So what will be this? This is a reference variable. This is a reference variable equals to new BST methods. So what is this now? This is my object creation. This is my object creation. Now since BST methods is called, that is the object creation, it will come here, where here, see, it will come here. This is a constructor and root will become null. Root will become null. It will initialize root to null. Now what I have to do, simply tree dot add 50. First we have to add 50, correct? So we are adding 50, done. Now after 50 we have to add 25. So let's see, let me add some values here. So the second value we are adding is 25. Tree dot add 25, 15. Now our code will take care of the rest. 15, 75. Whether to insert on the left or right, our code will take care of it. We do not have to take care whether to insert on the left side of it or on the right side of it, okay? We have written the code for it. So 30, 70, and after that we have 85, and then we have a 10, okay, 23. After 10 it is 23. After 23 it is 46. After 46, just write it down, you guys too. 46, after it is 84, and finally it is simply a 90. Okay, so this is my add method. So I have inserted all the elements. Now how will you see it? How will you see whether I have inserted this correctly or not? Okay, you need a order traversal. Now previously I have explained you about pre-order traversal, in-order traversal also, okay? So what you have to do is you have to write a code. You have to write a code for pre-order or in order here, and call this function from main, and he will show you whether it is inserted correctly or not. So tell me, what is the pre-order traversal for this? Just think and write it down on a paper. What is the pre-order traversal for my this binary tree, that the completed binary tree that I will have after I have inserted each and every node. So 70 will be inserted here, and this square, and 85 will be inserted here, correct? After 85, for 10 will be inserted here, 23 here. So I have completed this before also. What you have to do is you have to write down the pre-order traversal for this, and then we will check that with our code. So 46 inserted here, then 84 and 90. So tell me, what will be the pre-order traversal? Just think. I have explained a very basic concept that whenever, now I am going to explain. So pause the video if you want to try it by your own. So what I have explained is, whenever a node is visited for the first time in pre-order, we will print it. So when we print from here, so see, 50 is here, 50, we have encountered 50, so print 50. Then go to the bottom, and 25 is here, so print 25, correct? So go to the bottom again, and 15 is here. Oh yes, 15. Then 10 is here, so 10. Then comes 23. After that comes 30. After comes 46. I've explained you this how you have to do this, therefore I'm going fast. So the n is 75, after that 70, after that 80, 84, 90. So this is how our pre-order traversal is. This is what our pre-order traversal is. Every node once visited for the first time, we will print it, okay? So 50, 25, 15, 10, 23, then it will come to 30, 46, then it will come to 75, 70, 85, 84 and 90. Yes, this is correct. So let us check. Write a pre-order traversal code. Pause the video now. I have explained you what is the pre-order traversal code for this, and call it from the main function and check whether this is my pre-order traversal or not. You can do the same thing for in-order and post-order also, okay? To check whether the elements are correctly added or not, what we have to do, we have to simply write a function for our pre-order traversal, and that is a very small function, just a 3-line code, as you remember. So void pre-order, just simply pre-order and a node, and we will simply contain a node, okay? Now if node is not equal to null, if node is not equal to null, what we have to do, we have to first print it. So node.data, node.data, print it. Yes, now see, I have made the same mistake again. Do not use ln here for the better representation. Then pre-order and node dot, what we have to do, left or right? We have to go left or we have to go right? We have to go left, because first we go left, we print, we go left, and then after that we go to the right side of it. Correct? So this is done. This is my pre-order code. Now just go here and call this code. So what we will do, tree, using the reference variable tree dot pre-order, and we will pass tree dot root. Yes. So now run the code and you will see the same pre-order that we have just written down. Okay. Now when the code is run, you can see here this is the same pre-order, 50, 25, 15, 10, 23. Correct? Let me just show you. See here. So this is the same pre-order code, 50, 25, 10, 23, 30, 46, 75, 70, 80. Oh, see, yes, it is 85. It is not wrong. Yes, not wrong. See, I have just written the value wrong. So 85, 84, and 90. Correct. So this is the pre-order code. So my BST tree is working fine. So this method to insert is working correctly. So to check this method, we return a pre-order code. So this was insertion in my binary tree. Next, we will see how we will delete a node from our binary tree. Okay.